Okay guys, please turn to page 472 in your textbooks, problem 9.2, and now we are given a circuit conducting loop lies on xy plane, and it has a radius of a equal to 0.2, and then it connected to the resistor here with a value of 4 ohm. And then the loop, guys, is being placed in Bt environment given as 40 sine 10 power of 4 t millitesla in z directions, right? So that's going to be our Bt directions. All right, so I'm going to solve this solution using more convenient form of a B field which only has a variable, right? Now let's say we have here a Bt. We define ourselves equal to B0 sine omega t z directions, and we know that the B0, guys, has value of 40 millitesla, and then omega has value of 10 power of 4 radian per second. Okay, all right, so let's recall our last lecture. When we talk about the transformer EMF, we're gonna have these two equations. The first one is negative d flux over dt, or the other one here you can use also negative integrations partial derivative of b dot ds. Okay guys, so let's let's use the second equation. For example, you can use other one also can. So now let's find this term first, the dB over dt, partial derivative of b. I have here from here b naught sine omega t. Now have here a b naught omega cos omega t in z directions. Okay, now let's substitute this expression into this second equation of EMF. So I have here the EMF and negative b naught omega cos omega t z directions. And now guys, the ds here actually a sample area of this loop, which also has a z directions and depends the variable of r and phi. I have here r dr dphi. So since we have area, so we must use double integrations. So the first one of limit for the phi 0 until 2 pi, and then the limit of r 0 until a. So if we're going to have this value, a negative b naught omega pi a squared cos omega t volts. Right guys, so this is our general expressions of EMF. Okay, now let's define ourselves our polarity of EMF. Let's see, we're going to find the EMF for this loop, positive and negative. So let's say here is our first terminal, and then here we're gonna have our second terminal. Is it okay guys? Alright, so now my questions, how do I know the I induced directions? Okay guys, bear in mind in this case we are dealing with sinusoid function which always alternate. Sometimes the B increase, sometimes the B decrease. So if you can recall, or you can see the diagram or waveform of the sinusoid waveform, let's say this is our axis of waveform. So now let's draw the B waveform. Since sinusoid we have here sine functions, Okay guys, so now if you can see from the waveform, the BT guys actually keep changing, right? At certain period it has the increments in B, or sometimes in other period it has a decrement in B. So you can see from the waveform here, from this point until this point, right? You can see guys, let's say we define as T1 or a quarter of full period. So the B guys actually increase, while when we start from this point until this point guys, let's say I will define as T2 or half of the period. Now the B actually decrease, is it? So now let's look at to these two situations. The first one, when the BT increase, right? This is our BT increase in terms of amplitude. Okay guys, so based on Lenz's law, the B induced will try to, or will act to oppose the changes of BT. So now the BT actually increase from here to here. So the B induced guy will try to oppose to make it less back to original value. Now that should be your B induced directions. The function of B induced guys try to oppose the B changes, right? So based on using your right hand rule, where your finger thumb showing your I induced directions, and then your B and your other fingers refer to your B induced directions. So by right, this is going to be our I induced directions. Alright guys, so since we have the I flowing clockwise direction, so we know that the V2 is higher potential than the V1, right? The terminal number 2 has higher potential than terminal number 1, so we can have the value of EMF which equal to negative value. Okay guys, so let's look at from this graph. For the first segment, the BT amplitude actually increase. Okay, so it will give us the negative value of EMF. Alright, let's look at here. For the case of first magnitude of BT increase, so we know that guys, the flux also will increase. So based on Lenz's law, the I induced will flow in clockwise directions, which will give the potential at second terminal is higher. So now we have the V2 will have higher potential than V1. So the EMF, which V1 minus V2, will have a negative value. So okay, this situation or this case exists or happen when T more than 0 until T equal to T1. Okay, this is what happened to this value, right? You can see for the first segment in the first cycle, so the B increase, so we're going to have the B induced in the other way around, pointing downwards, because the BT now pointing upwards, and the I induced will have in clockwise directions. So the V1 will have the lower value than the V2. Alright, now let's look at the second segment, which this segment, right? If you can see guys, from this segment, the BT amplitude actually decrease. So again, based on Lenz's law, the B induced will try to oppose the decrement of BT. So now since the BT still is upwards in Z positive Z directions, so the B induced also will go in the same directions, right? That's the B induced, guys. So again, using your right hand rule, your I induced will have these directions, the I induced. Right guys, so seen from that, we can see that when for the case of less than from T1 until T2. So the B amplitude, the BT amplitude actually start to drop or decrease. So from here we know that the flux changes also will decrease. So based on Lenz's law, the B induced will go also upwards, same direction with BT. So again, using your right hand rule, your I induced will go in counterclockwise directions, which will give the point number 1 at higher potential than point number 2. So now we have the V1 higher potential than V2. So again, to find the EMF that induced across the resistor, using this formula, again V1 minus V2 will have a positive value. Okay guys, so in short, for this segment, we know that the BT amplitude start to decrease, which will give us the value of EMF for the segment equal to positive value. Alright guys, so I hope you can grasp the idea on how we can simply check the I induced directions that due to the B changes, because our B now we are dealing with sinusoid functions, so by right it has two different conditions that must be carefully looked at. Alright, so I hope you can follow me, and all the best for your study. Thank you.